In this video, we're going to look at ordering numbers and finding prime factorizations of numbers. So, ordering numbers. Couple tips. You'll either get them in decimal format or in fraction format. If they're in decimals, I highly recommend that you organize them vertically so that way you can compare the place values accurately. Common mistakes often happen because you're doing it quickly and you don't write down the place values or compare the correct place values. So when I'm taking a look at these four numbers here, I'm going to actually write them vertically and line them up by the decimal point. So first number, so I got them lined up. So now I'm going to compare place values starting with the one spot here. So it looks like these 2's are clearly less than these 3's, so I'm going to look at these 2. Next I go down, or I go to the next right decimal point, or place value. So 0 is clearly less than 8, so this value, 2.0549, is going to be our least value. So 2.0549. There's no other 2 values, so we know immediately then 2.85199 is our next least value. Now I'm looking at the 3's here, so they tie. I go to the next point, next place value, they tie, they're both a 2. I go to the next place value. This top one, 3 is less than 7, so this top value is smaller. So 3.2375 and then 3.27. So that's our answer there. So over here, what do you do when you have fractions? You can convert into common denominators if possible, or you can just change them into decimals if that's easier too as well. So I'm going to convert into decimal. First place value, the ones, they're all tied. So I go to the next one. Smallest value here, 5, 7, 6, and an 8. So it looks like the 5 is going to be the smallest value. The 6 then next, then the 7, and then the 8. Now I'm going to convert them back into the fractions. So 0.5 was the 1/2, 0.625 was the 5/8, 0.75 was the 3/4, and then 7/8 was our last one. So that's going to be our answer here. All right, how do we find the prime factorization of a number? You've got to find a factor pair. So you got to go back a couple lessons and remember factor pair is two numbers that multiply to be the given number. And then you want to continuously break down those numbers until you're not left with nothing but prime numbers, right? Because it ends there. And then collect all those prime numbers into a product. So first example here. Okay. So 54, I'm going to check to see what's a factor of 54. Immediately what comes into my mind would be 9 and 6. Now you might have something different, and that's okay. Eventually you'll come out with the same prime factorization. So 9 and 6, neither of those are prime. So I'm going to break up the 9. That breaks up to be a 3, which is prime, and a 3, which is prime. 6 breaks apart to be a 2 and a 3, both of which are prime. So now when I rewrite this, right, our branches are all done, and I like to circle my primes, just as a good organizational tool. I write down it as a product. So 2 times 3 times 3 times 3. This is the prime factorization then. All right, for 20, right, I know 10 goes into 20 because the one spot has a 0, and it pairs up with the 2. Well, 2 is prime, so I'm going to circle that immediately. 10 is not. 10 also has can be multiplied with 5 and a 2. So all the branches are done. We can write out 2 times 2 times 5. That's the prime factorization of 20. Taking a look at 24 next. 24, two numbers that multiply by 24. For me, what comes to mind? 2 and 12. Now again, you might have something different like 8 and 3 or 4 and 6. All of them are valid. If you, however, choose 1 and 24, it's not going to get you very far. 2 is prime. 12 is not. 12 to me, it can break up to be 3 and 4. 3 is prime. 4 is not. 4 breaks up to be 2 and 2. So all the branches are done. We've got our primes. 2 times 2 times 2 times 3. There's our prime factorization. 41. A couple checks here. 2 does not go into it because the one spot has a 1. 3 does not, or 5 doesn't go into it because it doesn't end in a 0 or 5. 10 doesn't. 3 does not because 4 plus 1 is 5. 9 doesn't either. Looks like this is 41 turns out to be prime. So that's our answer, 41. Now it is helpful to actually memorize what your prime numbers are. If you can memorize most of the prime numbers up to 60, you're in pretty good shape. Really good shape, actually. If you can at least memorize your prime numbers up to 20, I would say you're pretty average, and that's solid. 45. Let's take a look at this one. 2 doesn't go into this one because it does. The one spot has a 5. 5 does. So let's change my colors. 5 and 9. 5 is prime. 9 is not prime. It is 3 and 3. So 3 times 3 times 5. That is a prime factorization of 45.